Hello, everyone. Today is Saturday, February 21st. This is week 16, day 4 of India Evening and Weekend Platoon, and today's the last lesson of our AI unit. We're going to be talking about multi-classification as it applies to LLM models. This is actually a pretty dense topic, so I'm going to try to teach it kind of in the same. Give me one second. I'm going to try to teach it kind of in the same manner that I've been teaching all of my lessons because I feel like they're kind of intractable. And when you're barely getting into this field, I think learning how to program is hard enough. And then they add this AI layer to it, which is moving very quickly, and it makes things really overwhelming. So we're going to start with just a little conversation once again to kind of soft introduce this lesson. I'll go over the README, but honestly, you guys can read the README and it's incredibly dense. So I'll go over it. And if you want to go back and read it, you're more than welcome to. But I'm going to teach it in this manner because I think it's a little bit more user friendly. Okay. We're going to start off by just going over the first text conversation, one right here. And it's just two text messages. It's me and a buddy. And Gmo, myself, says, "Hey, are you coming to Big Willie's for a drink tonight?" And the buddy says, "No, can't go out tonight." What are the possible outcomes of scenario one?
It'd be okay. That's cool. Sorry to hear that. I mean, it's going to be a response from Gmo probably.
Yeah, it's gonna be a response for Gmo, but for Buddy coming out to have a drink, what are the only possible outcomes? You're talking about like conversations, right? And that's actually way too complex for this, right?
Yes or
So
no?
Like yes or
there you
no?
go. Yes or no. And this is what kind of classification?
Bullying?
Yeah. It's just binary, right? It's a one or a zero. It's a yes or a no, or it's true or false, right? Either you're going or you're not going. You can't halfway be there, right? And I say that facetiously, but I you can't actually be halfway there, right? There's only two possible outcomes, right? This is known as what kind of classification? I think you studied it on Thursday or earlier in the week. We're studying multi-classification today, but you already covered this. It's not multi, it's a one or a zero. It's binary, it's binary classification, right? Yes? Did we already study that? Sorry if I'm coughing, I'm a little sick. We did study that, yes? Binary classification, that's what this is right here. This is an illustration of that. Somebody say something. You guys already touched on this, right?
I'm honestly not sure.
Okay. Real answer. I think that should have already been covered. If it's not, we're going to cover it ad hoc here. So this is known as binary classification, and this is actually really easy. Someone state the obvious. Why is this really easy for LLMs to do?
It's either a
To
yes or a no.
Yeah, it's really easy for you to train an LLM on this, right? Because there's only two possible outcomes, right? It's a simple yes or no. It's like a light switch. It's either on or off. A light switch can't be half on, just like you can't be halfway at the bar, right? So this is actually really simple, and LLMs are actually really good at this. But this is kind of known, and I'm going to get into it a little bit later, but this is kind of known as kind of a closed system. This is really easy, right? There's only two possible outcomes, right? There's only two doors. If you don't go in one door, you go into the other. That's it. Easy. What we're going to discuss today is a lot more complicated, right? It's known as multi-classification. Let's look at example 2 here. Here's another normal text conversation. Chimo, I just got to the bar and they have $2 pints and playing nothing but Nickelback. Buddy, no way. I'm going to shower and jump in an Uber in 40 minutes. I've already trained this LLM with 3 classifications or 3 possible outcomes: sad, mad, or stoked. Given this exchange, which of these outcomes do you think the LLM is going to pick?
Stoked.
Like, yeah, if you trained it even half decently, this is stoked. This is super stoked. The other two don't even make sense, right?
Could be mad if he was late, I guess, but
Yeah, potentially, right? But it's pretty clear that it would be stoked here, right? He's like, yo, get a jump in the shower. Okay. So this is harder for really simply just because there's more possible outcomes. And anytime you have more possible outcomes, you're going to need more training data, more compute, more resources. Put a bow on that, more resources, right? And anytime you're talking about more resources, you're really just talking about more what? More
memory.
money. But memory costs
Money.
money. You're always talking about money. Anytime people talk about resources in tech, every single time, it doesn't really even matter the context. It really just always comes up. That's it. Pretty much like everything else. Alrighty. But especially in tech. Okay. So there you go. So here is an example of a multi-classification problem. It's not a 1 or a 2. I mean, it's not a 0 or a 1. It's not binary. There could be multiple. But notice, if I train my LLM on just these three, it's going to have to pick on one of those three based on the context or the input that it's given. Okay. Let's get really deep in the well here. Let's look at conversation 3 here. Okay. I don't want this to show just yet. Let's look at conversation 3 here. Oh, sorry, give me a second. Yet another normal text conversation. We have Chimo. Hey, have you looked at today's homework? What do you think of it? Buddy responds, I'm hungry. Possible outcomes you trained your model on are sad, mad, and stoked. Given this scenario, this is a big brain question here. What do you think the model picks and why? What happens here? What's the AI? What's the model's response here given the above scenario?
Confused.
You're on the right track. It's definitely confused, but what's it going to output? Anyone know? You haven't been taught this, but understanding this is probably the most important thing you need to understand for today, actually. Just understanding how they work is really important.
I mean, it looks to me like there's like a context error. Literally, like I'm hungry is a weird response to the question. So
Okay, absolutely. So what does the AI melt down? What happens? Does the model melt down? What does it do? I need to know. There is a right answer here, by the way.
would it ask questions?
Can't do that.
I think it returns the closest matched response.
Say that one more time, Venetia.
It returns like closest matched response.
It does. So what would it be here?
I'm hungry.
Look at the possible outcomes. You gave the right answer, and now pick one. Actually, pick doesn't really matter here. It's just the fact that you conceptually understand what the model would do that's important. Say what you said again. What's the model going to do?
Pick the closest matched response.
Yep.
So we have it trained to sad, mad, or stoked, but for some reason the closest match is I'm hungry versus the
No.
ones that we wanted to respond.
No.
You'd be sad, right?
Okay. This is why this is the hardest part to understand about this. Okay. Look at this conversation. Hey, have you looked at today's homework? What do you think of it? When your model has only been trained on these classifications, it has to pick one of these three. And it actually doesn't matter which one it picks because it's wrong anyway. That's how LLMs work.
Oh, I thought. Sorry. Yeah, I thought the buddy was the LLM. That's
Oh, no. Buddy's just a buddy.
okay.
Does everyone understand that? Now, that's not easy to understand, right? But I need everyone to conceptually understand.
So it could return any one of those three. Yes.
It's going to fit a square block into a round hole to the best of its ability. Because that's the only thing it can do. That's what it was trained to do. It cannot think outside of that. And actually, I don't want to use the word think because LLM models don't think. Roughly, this is kind of jumping ahead, but I'll go ahead and cover it right now. Roughly, this is what would happen, right? SAD would be like a, 3% chance. MAD would be like a 34. I'm just making up these numbers, 34% chance, right? And then Stoke would be like a 67 or whatever the difference is, 57. Is that right? 37, no, 67. Yeah, 63. I'm stupid. 63% chance. So it picks Stoke. We're going to get into the percents here in a second, right? But roughly, this is what would happen. Are any of these right? No, they're not. But it has to pick one. You ever wonder when you ask an LLM something and it doesn't know, what does it try to do? It wasn't trained to say, I don't know. It doesn't know how to do that. So it gives you what?
The
Next
closest
closest
answer.
available answer.
The closest answer, regardless if it even answered your question, regardless if it even contextually it would even make sense. That's why that happens. So ultimately, and here's a big brain thing. All LLM models are ultimately just closed systems. And they're closed systems because you have someone creating the classifications. You have a human. But in the real world, the real world is an open system. There is an infinite number of choices for everything, right? When I started class, I could have started it the same way. I could have been a little cheeky, be like, hey, AI hype train, Guillermo, G Money, DJ G Money's on the ones and twos. There is literally an infinite number of ways I could have started class, right? Because real world is an open system. You can't possibly put an infinite number of choices into an LLM model. So remember when people keep pushing this, and this is my own high take, feel free to think for yourself. You know how people keep pushing this like Gen AI, it gets there? It never gets there. It's impossible. If it gets there, that's
I was gonna
endgame.
ask. I'm sorry.
Go ahead, Brian.
I was gonna ask you that because I mean, these AI bosses keep insisting that one day, like if you're a developer now, your job is going to get replaced. I mean, I even Elon said like a couple of days ago, he was like, if you're just sitting there and you're just typing in code, your job is going to get replaced. And I'm like,
Uh,
I don't think that's going to happen.
I think all those jobs will get replaced, but you're going to still ultimately need a person to design it and oversee it, right? And do the big
Yeah.
thinking. You know how the higher you go up in like management, you just have more meetings, but the
Mhm.
decisions have an exponential impact on the org. That's ultimately what the developers will do. Yeah, maybe you'll have less, but their decisions will matter a great deal more.
It
Does that?
I was looking at some stuff and they were arguing that uh software engineers are going to be more like designers and not actually typing in the code. So you would
Designers is a good parallel, I guess, but I've met real designers and they're like super artsy and very talented. So if you ever met like a good UX UI person, you just realize that, whoa, those guys, like, it's
Or
not
maybe,
just a Google search, right? They're really talented.
I mean, maybe designer is wrong. Maybe architect is
Yeah, like
better.
an architect. Yeah, that's
Yeah,
probably a slightly better frame, better
yeah.
word. Okay, this was a lot here. Questions about just these big ideas involving these three text conversations.
I did some reading uh, of the material, and they have code in it, and I don't see like there's like not a repo for it, and I'm wondering, I mean, are we intended to use that code to make like bots?
No, no, I'll go over it in a second. It's just example snippets. That's all it is.
Okay.
But the two assignments I posted in the Slack channel, those are homework assignments, and they're derived straight from the lesson, from the README, with actual code snippets in there and helpful hints. So that should kind of close the loop on that one. Okay. Just to recap before we get into kind of a summary and the actual pretty dense README. Binary classification is really easy for LLMs to do. It's just a simple yes or no. 0, 1, black and white, light switch on and off. Easy. Because if it's not one, it's the other. Pretty straightforward. LLMs excel at this. Really, really good. But even you would excel at it, right? Because you, at worst, what percentage do you have of getting it right at worst? 50%, right? So when you say LLMs are really good at it, that's not that impressive, honestly, right? Because at worst, you're 50%, right? All right, so this is really good. This starts getting really complicated, right? Because how many different kinds of classifications can you get? Right here, I gave you 3, but how many human emotions is there? There isn't an infinite number of human emotions, but there's more than 3, right? There's a handful, right? So it starts getting more complicated, and that's just human emotions, right? When you start talking about like what humans can do in an open system like life, like the world, right? That's an infinite number pretty much, right? Of how you can go about your business, right? Like if I told you how many ways can you go to work, right? Think about this. When you drive to work, you could drive there, you could take the bus, you could walk there, you could ask a friend for a ride, you can ask a different friend for a ride, right? But those are just the simple answers. If you really started writing a list, right, it would be almost infinite, right? I bet you never thought of cartwheeling to work. I bet you never thought of hopping on one foot to work, right? I bet you didn't think of hopping on the bus for a third of the way, right? Then renting a scooter for another percentage of the ride, right? And then hitchhiking the last 400 meters instead of walking. Anybody ever think of doing that? Now, I'm being ridiculous, but all those in an open system are possible, right? Some of it doesn't even make sense. Like, why would you hitchhike the last 400 meters so you could walk there? It doesn't have to make sense. What matters is that it's an option and it can be executed, right? So that's what this makes this way harder. And the big limitation here of multi-classification models is the fact that someone has to go in there and create the classifications, right? So that's the one thing that I want you to really keep in mind. Binary is easy, is a 1 or a 0. Multi-classification is a lot harder because there's a lot of different classifications or options or doors to walk through. But again, also a closed system because someone is saying, hey, we're only going to have 7 different options. And if you only have 7 different options and you ask that model a question, right, it's going to pigeonhole your request, your input into one of the 7. That's all it can do. It's going to force it, even if it is a square block, into a round hole. Does everyone understand that? Okay. Super important conceptually that you understand that, right? And that's actually the third example. I just covered it, right? This idea that you're limited by the classifications that someone has already coded into the model, right? Cool. All righty. These are just a couple of lecture notes I want to go over just very briefly before we jumped into the incredibly dense README. And we talked about binary versus multi-class. This is just this idea that you have more options, right? Model structure, we're going to get into it in the README, right? But this is just turns clues into numbers. Remember when we were doing language parsing and I made an offhanded comment that some words are weighted more than others? Remember that? The concept is the same, right? It's going to take your input and some of the things that you say are going to be weighted differently, right? Let me give you an example, right? You're texting, you're texting back and forth. You're on a date. Let's go full Casanova on this. You're on a date and you're texting back and forth with your friend, right? How's the date going? You know, you went to the bathroom, you're texting them real quick, or you're texting her, whoever, right? And the text exchange is something along the lines of, yeah, it's going good, conversation's good, right? But then you start mentioning, right, that he or she, you know, put her hand on your shoulder and you're very comfortable with touch on that specific date, right? What's more valuable in that text exchange, right? The fact the conversation is good, or the fact that touching has now become comfortable on the first date? Which is weighted more, do you think?
The comfortability.
Yeah, the touch. So your friend is going to pick up on that. That's way more powerful than saying, hey, that conversation's good. I mean, it's great that the conversation is good, but the fact that you have gotten on day one comfortable, right, with touch should be weighted more. And those are the hints that the LLM has to be given. Like you and I can pick up on that, but an LLM has to be specifically trained to pick up on those inputs and weigh them disproportionately because they dominate in terms of how that date is going. That was kind of a weird dating example, but that's kind of what came to mind. Does that make sense? Okay. Cool. All right, so we talked about binary, we talked about clues into numbers and like this idea of weights, right? The next thing we're going to cover is raw scores to normalized ones. I talked about weights and numbers that are assigned to certain clues. We talked about language parsing and certain words being weighted heavier. It's the same thing here, right? Certain inputs are weighed more, but then eventually they need to be normalized. And that whole percentage, all of the clues together, right, have to be kind of calculated, normalized into like 100 percentile, right? Because it's going to give you a percent that humans can understand, right? The likelihood of something happening or the likelihood of one option being true. Make sense? Okay. Fourth one, we're going to talk about it. There's actual terminology for it, is the penalty for being wrong, right? This idea of like when a model is wrong, they go back in there and they say, hey, you've been making this mistake a lot. Let's see if we can change the weight distribution of the inputs you get to get closer to the truth more often than not. Make sense? Yes? A very simple example, going back to the dating example, is if the model picked up on, hey, good conversation and physical touch, and both of those are weighted the same. Make sense? They can't be weighted the same. because one is significantly more powerful and a better indicator of something going well. Yes? Yes, yes, yes. Oh, I don't know if any of you guys ever actually consciously thought about this, but just remember, there's only two reasons someone ever invades your personal space: to love you or to hurt you. That's it. There's really no other one, right? Penalty for being wrong, and then number 5, and we're going to touch on it in the README. It's just interpreting the predictions, right? How the machine kind of picks a winner, what they think is the most likely outcome. All right, so we're going to talk about these 5 things here shortly. But this is kind of conceptually what I want you to be thinking about when it comes to multi-classification. All right. This is the actual README. It's super dense, so I'm just kind of gloss over a lot of it that we've already discussed, right? But if there are any questions, I'll try to attempt to answer them to the best of my ability, right? So, what is the goal of multi-classification? Does anyone know? Why do we have binary classification, and then why do we have multi-classification? We're trying to do what?
Make more logical decisions.
Yeah. Can you expand on that in any way, Scott? You're right.
Oh yeah, there's nuances, right? So if you're 0 to 1, then you're either yes or no, and you don't have that many options. But you can have a little more nuance, like your example with the date. Like there could be an in between spot, and so now you need more multi-classification, I guess.
Yeah. So what we're trying to really do is just mimic the real world, right? You can't get to generative AI if that's even a realistic goal without this, right? If a Gen AI agent is ever able to do what humans can do, they need to be able to do all this and more. Because a 5-year-old can do it, right? If you approach a 5-year-old with your hand raised like you're going to hit them, what's the 5-year-old going to do?
Mine blow up.
Run, start crying, cower. They know what's coming, right? They can do that, right? With immaculate precision. But all of that you would have to train an LLM to understand. Notice, no words were exchanged in this scenario. You simply approached with your hand raised. And a 5-year-old will be able to pick up if you're trying to hurt. Does everyone understand that? Okay. All right, so model structure, hidden layers, activation. I'm not going to touch on this. This is a little confusing, right? But multi-classification, why we need it, what it is, we've covered it. All right, so let's talk about softmax. And this is some of the terminology that I didn't cover in the earlier example. Softmax is an activation function used in the output layer of a neural network for multi-class classification. It converts raw output scores called logits, I believe, into probabilities, ensuring that the sum of the probabilities for all classes is 1. And in this scenario, 1 is just 100%. The only thing that this is saying, right, is that, hey, it's a normalizer function that more or less, a little bit of an oversimplification, but weights the input. That's all you need to know. Does everyone understand that? It weights the input. Whatever the input it's taking in, it's going to weight it because not every word, just like in language parsing, for every input should be weighted equally, right? I'll give you the language example. You have two words, the and drinking. Which one should be weighted more? The or drinking? Come on.
Drinking.
Drinking. Higher level of speech. It's a verb. It's probably explaining what's happening in that context, right? Something's being drank, right? Now we just stemmed it. Yes? All right. Cool. So softmax does that, right? It converts this raw output scores to a probability that humans can understand, like the probability of something happening or someone walking through that door. And that's just an analogy with just picking an outcome, right? That's all it is, right? And this really goes into using PyTorch, right, to create this multi-classification model, right? And actually, I do want to go back up to this, right? And when we talk about the hidden layers here, right? These hidden layers, the crux of these hidden layers are just the different types of classifications, right? I won't go too deep into it because frankly, it's kind of outside of my scope of my realm of expertise, right? But these hidden layers are just that, hey, how many different classifications are you going to have? Are you going to have 3? Are you going to have 100? What is it? Are the options sad, mad, and hungry? Or is it bigger than that? And obviously, the more classifications you have, the bigger the LLM. Why is that?
It's holding more data, so it's going to take up more space.
Yep. And it's going to need more compute. It's going to get enormous. Right? You ever hear any of the big AI giants talk about, these big data centers that they need to build? Well, they need to build it, right? Because if you want the most power, if you really are trying to get to Gen AI, you're going to need the biggest data centers in the world, right? Because you're effectively trying to solve an open system problem with an infinite number of possibilities. Because that's what a human can do, right? Cool. So this PyTorch, right, is just a library that helps you create these classification models. Here it kind of goes into how you're going to do it. And it talks a lot about layers, right? But layers really just are directly correlated with how many different kinds of classifications you're going to have. If you have 3 different classifications, you're only going to have a couple layers. If you have 50 classifications, you're going to have way more layers, right? It's pretty linear. Well, although I don't know if it could be any bigger than that, but yeah, it's typically pretty linear. Just think about, hey, if you're going to have more options, you're going to have more layers. That's it. It's a more complex system. Not much more than that, really. We talked about weights and biases. Here's an example of it in code, but just think that, hey, weighted input, right? Some input's just way more valuable than others, right? Some of it are stop words. They don't mean anything, right? Let's go back to the dating example, right? If the person you're on a date with is laughing at all your jokes and you know you're not that funny, is that good or bad? I know this happened to many of you.
Probably bad because they have a terrible sense of humor.
No,
That 'cause
Scott,
they're a
good.
spy.
Were you referencing the Russian spies, Jose? Is that what you said that?
Yeah, yeah. If you know
Infiltrating
you're
the tech
ugly,
companies?
yeah. If you know you're
Whoa,
ugly,
whoa, Jose.
and you only get offended if it's true.
All
But
right.
but it's yeah, it's a real thing for sure.
Okay. You guys kind of derailed my example, but that's typically a good thing, right? Laughing at people's jokes, right? Okay. Explaining model predictions, right? We talked about weights, not going to expand on that, but explaining model predictions, this is important. Model predictions and multi-class classification models are interpreted by finding the class with the highest probability, right? This is just a little example how you would do it with PyTorch, but multi-classifications will do exactly what I explained here. Well, we'll try to find where all your input fits within their classification system. And if it doesn't fit one of those classes, what does the model do?
Goes for the closest match.
Goes for the closest match. Fits that square box into the circle hole. That's by far the most important thing you have to learn today. If you understand conceptually how these work, then kind of when you interact with them, not kind of, when you interact with them, you understand what's happening and why their output isn't what you need. If that happens, you're effectively, one of two things is typically happening. One, you didn't ask it properly, you didn't prompt it properly, or two, it doesn't have an answer for you and it's going to give you something regardless if it helps you or not. It has to give you something. That's how it's built. Here's a thinking question. If one day you ask an LLM something and it says, I don't know, they've effectively built what into it? I'm going to ask it again. If one day you go to Grok or Gemini or ChatGPT and you ask it something that it doesn't know and it responds with, hey, I don't know, what have they effectively built into that LLM? What kind of classification? This is probably the next thing that's coming, by the way.
What was the question again?
If one day you go to one of the LLMs and you ask it something and it responds with, I don't know, what effectively have they built into that LLM now? The answer is on line 37.
Defaulting to the weighted, you're building in a don't know answer. So if none of them are higher than 90%, then you can ultimately just fall back to I don't know,
It's the last else statement, right?
or a fallback, I guess. Yeah.
Yeah. A try catch, if you will. That's all it is. It would look, and this is the next thing that's coming, by the way. So this is the model's response, right? It forces you. It doesn't force you. It's forced to, just the way that it's written, right? To pick one, even if it has to fit a square box in a round hole. But the next iteration here should be an improvement on it, right? Where it would, if it's only mapped to three things, sad, mad, and stoked, right? It would give a percentage for each, but there would also be a classification for not knowing, right? So don't know, right? I'm just gonna, it always has to add to 100%. Here would be 90%, and there might be a threshold for confidence. So imagine if none of the current classifications reach, 80% plus. Default to, don't know. That hasn't been built into it yet, but it will be. Because that would be helpful, right?
So, based on this, you know how sometimes you ask like ChatGPT a question, right? And then you get like a response, and then it like for some reason it doesn't make a decision. It says this is response one, this is response two, and you have to pick. You're basically being the tiebreaker because for some reason those two responses, there's two possible responses almost tied together weight wise, and so it's asking you to pick one of the two because you're the tiebreaker, and then when you pick that response, it's weighting whatever else is in that response because there's some variations in there, so you're basically honing it down into like helping it add more weight to based on your response.
Yes,
So
and don't think they're not taking your feedback and training on it too.
yeah, goodbye, my friend.
Does everyone understand that here on line 37? Again, I can't tell the future, but my guess is that's pretty close to coming to fruition here soon. Because this little measure here, right? It's really helpful, and it improves user experience. It limits hallucinations, right? It makes sense. It would be the next iteration, right? All right. Cool. We talked about explaining model predictions, and then this gives you a little snippet on how to do it. So this is a really technical term. I'll try to go over it. Cross entropy loss is just a loss function, right? I'm going to describe it this way. This is kind of the judge that says, hey, was your answer right or was it wrong? If it's wrong, right, it's penalized, right? If it's right, it's optimized, right? That's all it is, right? What's the purpose of these loss functions is to improve the performance of the model. Make sense? I'll give you an example, back to the dating example. Good conversation, right? Physical touch. Initially, if they train the model and they weight them evenly, they'd be wrong a lot, right? Because one of them is a lot more powerful of an indicator. But eventually, right, because of this loss function and because of proper weighting of the input, eventually physical touch would be weighted more, right? And it would get the signal saying, hey, this one's a lot more powerful indicator, improve the model's performance, right? And then it will be right a lot more. So that's the whole point of this. Backstep, you can kind of talk about this. This is really technical. I wouldn't be too concerned with learning this. As long as you understand the loss function, I think you're gonna be fine, right? Understand that, hey, this is just kind of the judge of, hey, did you do it right? Did you do it wrong? Right? If you did it wrong, you're penalized. If you do it right, it's optimized to better weight everything. This goes into the training loop. You can read into that. I'm not going to kind of get into the evaluation or the training loop. You can read about it in the README. It's probably pretty dense, so I wouldn't focus too much on it. Let's touch on the conclusion briefly. This lecture covered the fundamentals of multi-classification models, including the differences between binary classification, a simple 1 or a 0, right? And multi-classification where you have more than 2 options. It talks about model structure, data processing, training tools, and building and evaluating models. The evaluation piece I kind of glossed over, but I think you could gloss over it as well. It's not that important. The main thing you need to understand from this lesson is really just understanding how multi-classification works conceptually. And as part of the homework, we're going to try to implement something pretty easy to kind of get your feet wet on understanding how this works. questions about multi-classification? No questions? This lesson is, to me, is probably one of the hardest ones in the AI ML unit. So if you're a little confused, super, super normal. It's not stuff that I personally really deal with every day, but you do sit in meetings where a lot of this stuff gets thrown around sometimes. So it's important to conceptually understand at the very least what's happening. Again, like I said before, you probably won't be training AI ML models unless you end up in a role like that, but you will deal with it at least in passing when dealing with data, right? Processing this type of data for LLM models, because that's the new hotness right now. Last chance for questions on multi-classification or why this is important. Alrighty, let's look at the first assignment. Sorry, I was checking the time, make sure I didn't. Yeah, too long, but it's only 48 minutes. We're good. All right, we're gonna work on this assignment. It's in the README. Let's look at it briefly. So assignment one, foundation, it's just called foundations assignment one. This assignment will test your understanding of the fundamental concepts of multi-classification models as described in the lesson. There's some conceptual questions here I want you to kind of focus on, right, before jumping in to completing this model architecture. In your own words, what is the purpose of softmax activation function? How does it differ from simple argmax and function? So here, in simple everyday terms, yes, be familiar with the technical jargon, but I think just initially being comfortable with conceptually what it is, I think is really important. Question two, explain the concept of cross entropy loss. Why is it suitable loss function for multi-classification models? Again, just in simple everyday terms, right? Don't have to get overly technical as long as conceptually you understand what it's supposed to do. That's going to be good enough for right now, honestly. And then what is the main difference between binary and multi-classification in terms of model output and the loss function? This is probably the most important question of the three. Really think about this one. Also, I think technically it's probably the easiest too, but I still think it's the most important. We'll try to answer the first part of this now. What's the main difference between binary and multi-classification models? We'll answer this now. Ideas.
Level of complexity.
That's it. Nothing more to that. Just level of complexity. Zeros and ones are easy, man. Really easy for computers, for humans too. Unfortunately, the world is not binary, right? There's a whole spectrum of that makes this really difficult. All right. So code comprehension here, I ask a couple of fill in the blanks here, work through that. You're going to write a little bit of Python to give me the weights and biases of the student performance model. Why are weights and biases important here in the multi-classification model? Why are weights and biases important? So weighted biases appear in binary classification too, but they appear even more so in multi-classification. But why are they important? We've kind of already talked about it. Okay, let me kind of go back to binary real quick, and then we'll come back to multi-classification. There's a really famous binary classification example. It's called the Titanic example. Has anyone ever come across it? I'll give you the brief overview right now, and actually I'll post it in the Slack channel. There's a really famous binary classification problem that anyone interested in AI ML, it's like the first assignment that they do, right? Really famous. You can Google it, but I'll post the link here in the Slack channel shortly. It gives you the entire roster of everyone that was in the Titanic, and you're supposed to build a binary classification model to predict if the people on board lived or survived. And we have the actual records of everyone that died and survived. So then you cross-check it with real data and see how good your model is. Yes? Very simple. Let me give you just a characteristic, and I need you to tell me if this should be weighted more or less. Yes? The person on the ship was a man. More weight or less weight for survival?
What's the reason for applying the weight?
That's what I'm trying to get you guys to think about, Jose.
And we're trying to find out who just
Who survives and
from
who
the Titanic.
doesn't. Yeah, and I'm only going to give you one little factoid. All right, so we're trying to decide the likelihood that someone survived or didn't survive the Titanic shipwreck in just a very simple binary.
I would say less weight.
No. The person in question is a man. More or less weight to survival?
Be more weight.
More.
Why?
Well, if you base it off of the time period, it's probably because they were going to hop on the ship anyway. But if you base it off of science, it's probably because the males have a higher rate of body weight, so they're going to have more protection against the cold.
And more muscle too, right? So there you go. That should be weighted more. Let me give you another one.
I was going to say because whenever they're exfilling people, it was women and children first. So a lot of the men got left on the boat.
No, wrong thinking. All right, let me give you another one for binary, and then we'll jump back to multi-class. Let me give you another one for binary. The person in question was part of the poor class. More or less weight for survival?
Less.
Why?
They're probably not that healthy to begin with, and they're not
Nailed
eating
it.
as well.
That's it. You nailed it.
So is this where the what you were talking about, like AI isn't quite there yet, comes in? Because like that example there, you could also make an argument that the more poor class has a higher sense of survivability because they deal with more adversity.
Grittier, right? That's why it makes training these models so difficult, right? Like that would be dependent. That would be kind of dependent on the person, but in general, that what Manisha said is correct, right? They would just be malnourished, right? Given the time period, right? They'd have less fat on them, which makes them less likely to survive in cold water, right?
But that's an example of what you meant by like AI is not there, right?
Yeah,
Like
it's not there, but we need to train it to pick up on all of these clues, right? So that's a really simple Titanic binary classification, but you extrapolate from there, you go into multi-classification. I gave you the dating example. That's a lot more complicated and a lot more nuanced, right? I gave the example of good conversation versus like touch, right? Way more nuanced than, hey, was that dude rich or poor, or was he a female or a male? You see that? It's way more complicated, right? But given what people are trying to do, right? Really pushing this, hey, we get the Gen AI. Okay, cool. You need to train it to pick up on all this. Just like the example that I gave you about the 5-year-old, you raise your hand and you approach him, right? Your hand in like a fist. They're going to react to that. In the same way, you need to train your model like that. That's going to take a grotesque amount of compute
I think
and
that's
data.
where humans will always have the advantage. Well, at this point, we'll have the advantage because we already instantly went back to assessing the time period and all of that. Whereas right now, AI doesn't have enough sense to like know that we're also saying, well, think about that time period. It's just trying to answer the message in this time period with the physiological or whatever, the most black and white parts of it. But we're already thinking, well, it's that time period and all the other social aspects. It's we're still ahead of AI in that sense.
Because all of those variables, you have to write them into the code, right?
Because like when you raise I don't know, like even the 5-year-old, like what kind of 5-year-old? Like for me, I'm like if the 5-year-old has silver teeth, that kid's hitting back. Like
Here's the thing. Here's the thing, guys. Um, let me finish this, but let me give you the Mexico dog example. All right. So, and the last thing, we talk about using PyTorch, right, as a library that we're going to use. This ultimately gives you the predicted classes. And remember, these decimals always add up to 100% because it's trying to give you the most likely scenario. This is just a list. Option one, for example, here, right, 10%, 20%, 70%, right? So this is a good intro assignment, and this is what you're going to get started on. But I want to touch base on, I gave the example of kids. It can be a living organism that's not as smart as a human. This happens with dogs. Let me give you a real example. In America, stray dogs approach you because Americans treat their pets very well. When you go to Mexico, they don't approach you. Why don't they approach you? Because in Mexico, people beat those dogs. And they know that. All the dogs in Mexico know. Right? Stray dogs don't approach you. They run away because they think you're going to hurt them because everyone does. So it doesn't have to be a 5-year-old. It could be a dog with a fraction of the intellect. They're going to pick up on it. And that's something that's so hard for a machine to do. But even different organisms or living things that are not nearly as intelligent can do it flawlessly, quickly. I don't know if you guys have ever had a dog get hit by a car. The dog before it gets hit by a car and after it gets hit by a car are completely different. I don't know if you've noticed. Before it gets hit by a dog, it doesn't look at the street any different. After it gets hit by a car, all of a sudden it learns that you look both ways. I don't know if you guys had that experience. All of a sudden, magically learned. Does that make sense? Multi-classification. Ultimately, if the AI companies or just anyone in general is to get to the lofty goals that they have set, and they so avidly pitch in their keynotes, right? When they release their stock results or their earnings, right? They're going to have to solve that problem, right? This classification system has to be as good as a human, which is a tall task. Once you understand what they're trying to do, and I hope this gives you a little bit of insight into what they're trying to do, you realize how tall of a task it actually is, right? Does anyone know if we can turn lead into gold? Can we turn lead into gold?
Shouldn't be able to.
We can. What's the reason we don't? Does anyone know? It's kind of the reason why I don't turn salt water into drinking water. It's the same problem. We can do it, but why don't we do it?
Expensive.
the cost would exceed the value of the return, right? You have a similar problem here in AI. The value return, it's going to have to be massive to justify the expenditure. Now, it could be a turn salt water into water, right? Or turn lead into gold type of problem where, yeah, eventually we do figure it out, but the return is less than the expenditure. And I don't know if you know how much you know about business, but that's what's known as a bad business plan. Make sense? So that's kind of the issue. All right, so that last little piece, that's more of a hot take, I think, my own personal hot take. But it's something everyone here should be thinking about too, because but they have unlimited resources, i.e. the US government. I'm going to actually stop the recording here because I'm going to share something with you that I don't want recorded. This is definitely just a taste, and I hate to say it, just the tip of the iceberg, really. So we're just going to go over it very briefly. I don't want to destroy you any more than we already have with this. But I hope you find this stuff pretty cool. Yes, it's very dense, but it's also very dope. It's very, very sexy stuff to learn. All right, this is assignment 1. Let's go over it. Question 1, in your words, what is the purpose of a softmax function? Just in the simplest words you can think of, what is it? This function does what? Doesn't have to be overly technical, it just does what?
Gives you like a probability or
Yep.
like a guess,
That's it.
best guess.
This gives you a probability distribution. Things like A with 8% chance, B with a 56% chance, etc. Cool. Awesome. Let's look at number 2. What is the cross entropy loss? In simplest terms, just like number 1.
It,
Go ahead.
I was gonna say it's the gap between how wrong it is from the softmax.
Give me, yeah, but don't define something with the name of another thing you have to define.
Okay. How
The
far
gap
away it
is
is from the
right,
right
though.
answer.
Say that again?
How far away it is from the most probable answer.
Let's just put right with an asterisk, right answer.
Okay.
Yes?
Yeah.
I think this is part of this. We talked above of softmax. What's argmax? Argmax is just index of the highest probability. When it comes in a list, what's the index of the highest chance? That's it. That's the difference between
Right.
softmax and argmax. Right down here, what would be the argmax of line 53?
7.7.
Yeah, but it's asking for the index, so it would be
Index
actually
2.
yes. Good. That's all this is. And this right here is actually really important, how far it is from the right answer. And you get penalized if you're confidently wrong. Let me give you a really crazy example that drives me nuts because I think it's really dangerous in just in everyday life, but also with the rise of like fake news and everything. A couple of weeks ago or months ago, I was in Mexico with my dad, and I just stopped at a McDonald's so I could check my Slack from work. Right. And I don't like going to places and not buying anything if I use their Wi-Fi or their restroom. Like I'm one of those people that just always buy something, you know? So I am a patron of the establishment, right? So I sit down and I told my dad, hey, Dad, just give me a coffee, you know, while I check my Slack. Right. And he orders it, and it's been a while, and we're about to leave, and I never got my coffee. But at McDonald's, it doesn't take very long, right? Like you just pour it. It's not really much to it. And then one of the girls working there came over to me and my dad, and he's like, hey, have you got your order? Because you get your little number at McDonald's. Right. And I'm like, no. And he's like, my dad ordered it. And he's like, oh, did you get a receipt? And he said, no. And then I guess she kind of could tell that we're not Mexican. She's like, did you guys pay with an American card? And my dad said, yes. And she said, oh, yeah, we don't take American cards here. That's why I didn't work. Does anyone know what's wrong with her statement? If you don't know how the finance system works, then you might not catch this.
Thought Visa was universal or MasterCard was universal.
Okay, so you're kind of hitting on the right answer here. Does being an American card have anything to do with the establishment accepting the form of payment or no?
No.
It
No,
can due to the foreign exchange rate, though.
No, but even that has nothing to do with it being an American. It's not an America issue. It's a what issue? Does anyone know? It's a bank issue, right? It's the financial institution that backs the card. It actually has nothing to do with the country. But notice what her answer was. Oh, it's an American card. She was so confidently wrong. That is dangerous. And the cross entropy loss function will penalize you heavily for that. You cannot be confidently wrong because your answer and the correct answer are orders of magnitude. Not only are you wrong, right? But you've effectively created a new reality. Does that make sense?
It does.
Now, if you ever travel, that happens. That's not the first time that's happened to me. It happened to me in Argentina as well. And that is really dangerous. And it's just a lack of education, right? But the way that people communicate, right? You are very confidently wrong, and that is really dangerous, not only for us, but for models as well. Make sense? So just think of a ridiculous story like that, right? I didn't say anything to the girl because I would have to really reteach her wherever she learned that, right? She could have just shrugged it off and understood that she didn't really understand why I didn't take the card, right? But my guess is she probably parroted that from someone else, which is even more dangerous, right? Because now you have a bunch of people parroting things that aren't actually true at all. Does that make sense? Now, this function, the reason why we need to code this into our applications, because this should be heavily penalized, right? You don't get to the truth like that, right? Whereas if you were really uncertain and you made that code, the percentage was like 8% and you gave a guess and it was wrong, well, you knew that the model wasn't very confident in the answer. So you knew as a user, hey, this is probably not right. And there needs to be, like I was explaining earlier, some kind of threshold of credibility that is also established by whoever's building and training the models, right? Is that threshold 80%? Is that threshold 90%? If it's life or death, that threshold better be really high, right? Like 95%, 98%. Does that make sense?
Yeah.
Yes. Anybody ever get on Waymos? Anyone do take an Uber right now? In Austin, they're all over the place. You can't even get a real driver on Uber right now. It's all at Waymos. Anybody get on a Waymo?
No way.
Stop, dude.
No
They're safer
way.
than real people, man.
Aren't Waymos only
No.
in California or something though?
Nah, Austin's littered with them. So
Oh,
no
I
one
don't-
here
I
has
don't
ridden a
trust
Waymo.
No.
It's
I've
freaking
never gotten in a
dope.
Waymo.
Okay, it's freaking dope. But the example I was getting, no one's here has gotten on a Waymo, but if you ever get a chance, definitely try it. It's super cool. But there has to be a threshold the way that those things are configured, right? There's a threshold for any decisions that it makes, right? It needs to be absolutely with a high degree of confidence that, hey, it's okay to merge into that lane. There's no car there. That threshold's got to be 100% pretty much, right? If not, what happens?
Somebody gets hit.
Yeah.
Mhm.
What what did you think it was? Because I saw a news program, I think maybe last year, end of last year, and I think it was in California and the power went out and all the Waymos in that area just stopped. They
Yeah, I lost
didn't.
connection. That's probably the most dangerous thing.
Yeah. Well, my thing, okay, you stated earlier about AI, right? This feeds into the lecture, so I'm not veering off too much. But you stated earlier that if Waymo's operated off AI and AI can't make decisions like a human can, right? With the sense, the touch. Basically, you were saying like the five senses. It's just not at that capacity where a human is at with five senses. That's why I don't trust Waymo. Because when you're driving, you still need those five senses to make decisions. Now, I agree, not everybody is competent enough to maximize and be aware of all five of those senses, but there's still a higher degree of those five senses you need to make decisions quickly on the road that I still don't think AI and Waymo can do.
So driving is actually pretty easy, right? Their computer vision is really good because you follow a certain set of directions, and those classifications are pretty straightforward, right? I was describing like human skin absorbing moisture, right? That's on an
Yeah,
order of magnitude more difficult, at least, right? Than having one car not run into another if it's there,
true,
right?
true.
We're solving an easy problem, right? When you start getting into significantly more complicated problems, that's when it gets really, really dicey, right? But driving in itself, it's pretty easy, right? And it has a bunch of sensors. Webos are pretty good. They have like a million cameras. You ever see them? There's a reason for that, right? It needs to take continuous feedback. So does it run into
Oh,
anything?
to drive Waymo is to give into the machine.
Nah, they're common, buddy. All right, number 3. What is the main difference between binary and multi-class classification in terms of model output and loss function used? What's a simple answer to this? Binary is easy because why?
It only
Ones and
has one
zeros.
output.
Yeah, binary typically only has, oh, not typically, I'm just going to put always. Binary only has one input and one output, right? They ask a question and it's yes or no, right? You can't
Yeah.
halfway go to the bar. Definitely can't do that, right? You can go in the lake or you could not go in the lake. All right. So that's easy, but multi is hard because
It's weighted, different options.
way more inputs and outputs. See, that's it. That's the crux of the whole thing. Binary is easy. One input, one output. Yes or no. Going to the bar? Yes, no. Cool. Uh, hey, Scott, how are you feeling today?
I'm feeling great.
You made that really binary, but you could have gone with an almost infinite number of feelings, right?
Yeah.
So there you go. That's the difference, right? I could have been like, hey, is Scott alive right now? Yes, he is. He's not dead. Awesome. Easy. But I start asking really nuanced questions like how you feeling, right? You start going to have a lot of inputs, right? And let's just very briefly deconstruct that question. Hey, Scott, how are you feeling? Let's look at what inputs would go into an answer like that, right? How many hours of sleep he's had? Are his kids being bratty? Is the wife in a good mood? Did he already eat? Was his meal delicious? Did the Uber Eats forget the fries again? Like all those could potentially be inputs to, hey Scott, how you feeling today, buddy? You see that?
And just to illustrate your point, I got this hanging up on my wall for whatever reason, but that's supposed to be like a simplified emotion wheel.
Why do you have that? Is my first question.
So I can learn emotions.
Gotcha. Real engineer, he doesn't know what to do with his emotions.
Yeah. But
Alrighty.
it's just to illustrate like you can get very granular with so many things,
Yeah.
right? Like even in like a Modbus protocol where we send one register, you can still break that register into different bits. So it's a lot of options.
Yeah. Complicated. And anytime you start getting a lot of classifications or a lot of options, just remember you're burning through a bunch of compute storage and it's just money. That's really what it breaks down to. Okay, cool. We already got these first 3 questions. Let's walk through this very, very briefly. This is really just creating a class. This is a constructor. You're actually inheriting here from end module, which is just a library, right? In this specific scenario, let's break down the numbers just so you understand what they are. What's 13 here on line 30?
I had to look it up, but it's the inputs.
Yeah, the inputs. Remember when I asked God how he was feeling? And I told you, hey, there's probably a lot of inputs there, and I just rattled off a bunch of them. Let me rattle off a bunch here for this exercise. And there's not really any more context. I'm literally just making this up on the fly. But if I was to look at this code and say student performance model, the inputs, let me just make up inputs that I think would affect the student's performance. Does that sound good? I'm just going to make up inputs, and I think you guys would agree with most of them. Yes? Let's go. 13, I'm not going to rattle off 13 because I can't think of them, but I will rattle off a couple of inputs that will affect student performance. Parents, happily married, at home. Their socioeconomic status. The types of degrees or lack of degrees that their parents have. Whether the parents have a happy marriage or not. Whether they have siblings. I'm talking about student performance. Have you noticed how I haven't mentioned anything about intellect yet? Or work ethic? Those are hard to quantify, but those could be variables too, right? So all those inputs, I just made them all up. But if I was creating this student performance model, probably a lot of those would be in there for my model, because I think they're going to be a pretty good predictor for how well a student's going to perform, right? You get really abstract too. Something like total number of books your mom and dad read over the course of their life. I mean, who would have that data point? But that's, to me, a valid point. How well your kid's going to do. Make sense? It could be anything. It's almost unlimited, right? So those are the inputs. Go ahead.
It might be a better question for after you explain the outputs, but why are they broken up into layers like that? I guess that's my overall question is why are they in layers and not all in one large function? So like, add 13, 30, and 25 and have that many inputs. Is it a computational thing or just something else?
Okay, so this part starts to get real complicated, and I'm going to try to answer it here. If ultimately the output, if ultimately your model's multi-classification system only has 5 classifications, where does that number go? Where does 5 go? Look at this class, line 27 to 36. If there's only 5 classifications for your LLM, where does that number 5 go? Between line 27 and 37. Where does that 5 go?
It's the output, right?
It's the final output, so where is it? Give me a line number. This tells me if you conceptually understand what's happening in these layers, which is not
Line
easy.
36.
Well, which one, first or second?
Line 36.
Yeah.
What do you mean where does 5 go in there?
Yep.
5 is your input, right? So it'd go on the first blank line.
The final classification is only 5. The final number of classifications are only 5. So where does it go?
Oh, the second blank line.
Yeah, this ends here. So what is happening again? Gross oversimplification, right? You start with, hey, our model will track 13 inputs, right? And these 13 inputs will give us 30 outputs, and slowly but surely with every layer, more compute and more refinement get us to, hey, how do these 13 inputs distill into only 5 classifications?
Okay, so the output of one layer becomes the input of the layer after it.
Exactly.
Okay.
And you ultimately distill your 13 inputs into only 5 classifications, because that's the only thing the model can do, right? These numbers in here can vary wildly, The only thing you need to remember, it's just the way, what kind of functions you're using and how many layers you're using. Typically, the more layers, the better the model, but also the more compute, right? So these layers are just trying to figure out, right, the mathematical calculation between these inputs and which inputs are going to have the biggest impact on accurately predicting the 5 final classifications. Because remember, multi-classification models have to pick one of the 5, right? They have to, even if they're wrong. You see these hidden layers here? That's why I didn't kind of want to explain this. That's what's happening right here. It's taking all of your inputs, right? It's actually converting them to what they call logits or whatever, just numbers. It's vectorizing them, statistical probability that this input has a disproportionate impact on said outcome, distill it to your final 4 classifications. And then you weigh it, which is more likely. Not easy to understand, but conceptually, if you got that far, that's good enough for now. All right, cool. And then you can kind of figure this out. Line two here, question 2. Write a Python code snippet that would print the weights and biases of student performance model after it's been instantiated. How would this start? Anyone know?
With instantiating it.
Yeah. What do you want to call it? Just model? What are we instantiating? Student
Performance.
Yeah, why is it not auto-completing for student performance model? Oh, that's, yeah, it's fine. All right, we instantiate it, and then we do what?
Need to figure out which variables, the weights and biases.
Yep. In here, it would be really easy just to do what then? We know the named parameters, right? So I would actually write a little script here, but for this particular instance, you don't have to, right? You would just loop over it, right? And you could destructure it for name, right? Param in model. Model what? Whatever your named parameters are. Right? And then if, I should really write real code, right? If param, code here, and see if you can print them. I'm not going to give them to you, but I will post the answer here shortly. I want to give you guys a chance to finish this, and then just find the index. Right here on number 3. Questions about this assignment? It wasn't meant to be overly difficult. It was really just meant to kind of get you thinking about how this works conceptually. Even if the code kind of seems a little out there, as long as conceptually you understand what's happening, I think you're going to be just fine. What effectively is happening actually here? Well, it's here. It's happening all here. But in this hidden layers thing, what's happening? Your inputs are getting what?
To get narrowed down.
Not eventually narrowed down to your level of classifications, yes, but it's more than that. They're
But I mean,
getting what?
Is it getting iterated?
They're getting what?
I was gonna
Go
say,
ahead, Jose.
are they getting I can't even figure it out this morning. Iterated through?
That you have to iterate on that function that I showed you, right? That is the answer, but not quite, just conceptually. Even if you can't really technically come up with the right words, that's okay. In the hidden layers, let's go back to the student example and the made up inputs that I made up, right? I was talking about like whether your parents had college degrees, how many books they read, how much money they made, right? Those are all inputs, quantifiable, yes? We can calculate all that.
Hmm.
I mean, something as difficult as happy marriage is hard to quantify, but let's just say they're together, right? Just together, yes or no. We can quantify that, right? 0 or 1. Parents married, they both live in the same house, 0 or 1. We can do that, yes? How much money do they make together? Household income, we can quantify that. Also a number, yes? We can break that up into like a category of 5 incomes, right? Low, middle, high, upper high, rich, whatever. Yes? So we can quantify that too. Yes?
Hmm.
Whether they have a degree, 0 or 1? Yes? So look at those inputs. We can quantify that. What's actually happening is they're figuring out which of those, right? They're taking those zeros and ones, right? Putting weight on them, transforming them. These linear functions are actively transforming them, turning them into vectors, weighting them, and seeing how they impact the outcome to distill us down to the 5 classifications. That's all that's happening in these hidden layers here. Because conceptually, that's all you need to understand. And actually, if you go to really big models, these hidden layers are it's kind of well known to be a black box of how they calculate that. We don't really know. The assignment that I gave you here is super easy, so we could figure that out. But for really big models, it ends up being really complex.
When I looked it up, it said, think of it as like the first set of numbers is 13 and 30. And it said, think of the first number 13 as the raw 13 pieces of raw data and the 30 as 30 agents. So you take the 13 pieces of data and you spread it over 30 agents, and each of the agents picks a different part of the data that you have.
That's even more confusing, Brian. That may be true, I don't know, but that's confusing.
It makes sense to me, but maybe I have a weird brain that likes complications. I don't know. Maybe I'm
No, weird
autistic or
brains don't
something.
like complications. Genius is simple, right?
I don't know.
That may not be intuitive, but if you really think about it, all brilliant ideas are simple. That's what makes them brilliant.
Or I have a tendency to think backwards for most people, so
I think you need to think clearer. That's what I think, right?
I have a lot of clarity. I just think backwards.
I don't know what that means, dude. All right, questions about this multi-classification or about your assignment, actually. What's the number right here, line 34? The first number on line 34, what is it?
20.
And we can make the very next number what?
15.
Yeah, this is kind of an arbitrary number, right? But we know then that line 35, the first number is?
And then this one is
16.
Yep.
Line 35, first number is?
15.
15. And let's just go by fives. Why not? Why not? Right? And then we know that line 36 has to be something like that. Because it's just every layer is going to be distilling. Here's a good thinking exercise. Oh, that didn't do what I wanted it to do. I'm just going to do it this way. Everyone here witnessed the change that I made. Is this a more or less effective model?
Less.
Why?
Because it's not going it's not getting refined as much because you have just one middle layer as opposed to like 5.
You have the right answer, Brian, but I'm looking for a little bit of a cleaner answer, but that is right. This is a far less effective model. But why? Can
Maybe
anyone put it into clear
Scott can
terms
clean it
here?
up. Scott is good at
Scott, can you come in and save us here? We know that this is a less effective model, but can we explain why?
It doesn't iterate over it enough times to actually determine what the right probability of the answer is going to be, because you just jump right from 30 to 5 instead of going from 30 to here's the 25 most probable answers down to 20, so on and so forth, all the way down to 5.
Yes.
You're just killing it right from the beginning.
Yep. You haven't properly analyzed the inputs where you could weight them and vectorize them and normalize them effectively to get to a good probability that your model is going to be able to identify your input into the 5 classifications that you want. That's what's happening. Clear as mud? Actually, let me share my screen one more time before I cut you loose here. We can break for lunch after this, no worries. Can you guys see my screen?
Yeah.
Yes. Okay. So hopefully this lesson and hopefully prior lessons have kind of like helped you peek behind the curtain of some of these models and realize that it's not magic, right? Someone's writing these classifications, we're training them. Who's picking the inputs of these models?
The developer?
Yeah, the data scientists, right? So people. So you wonder why they're flawed. People are picking them. So they're gonna have flaws. Humans are flawed, right? Maybe they can't think of the optimal ones. Maybe they don't see the right inputs, or maybe they think some inputs, right, should be weighted more when they shouldn't be, right? So ultimately, all of these are closed systems, right? Because they're limited by whoever's building them, which is a human, right? The only way to achieve really a higher level than that is to build something that people always talk about machine learning, right? And building models that can train themselves. That's pretty much the only way to get there for that reason, right? But ultimately, this right here just shows you that we're just manipulating data, right? And trying to find the weights and biases of our model. But this is just manipulating data. This is just identifying the highest probability based on the little model that we trained, right? Who creates the classifications? In a multi-classification model, who creates the classifications?
The dev.
Yeah, whoever's building it. Who picks the input? Whoever's building it. What data do you input? Whatever data you can get. Whatever data you can create. Right? So I'll leave you guys with this before lunch. We're trying to build an open world solution, which is what generative AI aims to be. We're trying to create an open solution using closed processes. That, ladies and gentlemen, is impossible as it stands today. So when you hear about AI models needing to train themselves, that's right. That's the only way we can get there. Because humans can't keep picking everything. If not, we never get there. Does that make sense? That was a big brain statement. I hope that made sense, right? This idea of open world and closed world, or open systems and closed systems. Like the world that you and I live in is an open system. There's an infinite number of possibilities, pretty much, right? But the minute that you start going into the computing world, that's closed. And it's difficult to have a closed system mimic or perform on an open problem, which is what the world is.
I think I might want to challenge you on that.
Don't care, Brian. What I stated is correct.
Okay. Well, if you're absolutely sure.
Absolutely.
All
Any
right.
other questions? Oh, I'll leave it at this, guys. The burden, and I'll stop ranting, we'll go on lunch. The burden of proof to get this to work is, I'm actually pause it, turn off the recording right here. Let's go over assignment two. I don't want to say briefly because nothing I do is brief, it seems like. But what do you notice about assignment two that's very similar to assignment one?
It wants us to put it all together and make it actually work.
Yeah, and you also notice that the inputs and the classes are what? How many inputs are you accounting for in assignment two?
Three? Or no, because it's each of those numbers 13 going down to
13
5.
and going down to 5. Yeah, that's identical to assignment one, right? That was intentional. Okay, so start at the beginning is we're just going to create a dummy data set that we can work on, right? Pretty straightforward. These numbers are identical to assignment one, these two, right? And number of samples is just how much data you're going to use, right? Anybody look up what a tensor was by chance? Can anyone give us just a run-of-the-mill definition of what a tensor is?
A unit of measure, isn't it?
I don't know. I didn't interpret it that way. This is the way that I think of it. It's just a tool, right? That allows you to store and do a bunch of math on numbers. That's more or less what it is. And in this case, it's just a library and we're importing it. Because what are LLMs again? They're just what kind of models? What kind of responses are they going to give you? Statistical models, right? And actually, I think multi-classification kind of illustrates that perfectly, right? It's just percentages. Statistically, we think, hey, the car is behind door one and not door two, right? That's all it is. Okay, so here you're just actually creating a bunch of data, right? And then you are going to load it. And what's the split here behind, what's the split between training data and testing data?
What do you mean by what's the split?
It's a split, right? All right, you generate a bunch of data, right? And then you split it, right? You train it with 80% and then you test it with 20. Like that, depending on what you're doing, can vary a great deal. But typically a lion's share should be training and a small subset of that data should be used to validate whether your model is actually doing what you want it to do with a certain level of accuracy.
So
Does
you're
that make
saying,
sense?
so when you're testing it, you're testing like the variation, like you want to have it closer to 1 and or 0. It's just the variations of response and how close it is for accuracy.
Yeah.
I think I
So,
said
okay.
it. long wise.
Yeah, you
curves.
set it in
You're
the
measuring the
long-winded manner.
variation when you test it, you're measuring the variation and you want to have it closer to on than off.
Closer to right than wrong,
Yep.
right?
Yep.
I don't know if this has been explained to you, but this is actually really important. You cannot test a model's accuracy on the same data that you trained it on. Does everyone know that? I don't know if that's ever been covered. Can anyone explain why you can't test the model on any of the data it was trained on?
It already has that mapped.
Yeah, so its accuracy is going to be what percent on it?
100.
Yeah, that's why you can't. It's already seen that pattern. You're leaning into what computers do great, right? Identifying specific patterns and sending them your way. So that's the reason why this happens, right? So to get data that is very similar to what you trained it on and have it predict the right answer is really, really, really important. But you need to keep those two subsets of data separate, right? So keep that in mind if that hasn't been explained to you. This right here is your training loader. You're just loading your training data, and you're also loading your testing data here. Something we never really talk about, but it actually comes up in software all the time. Anybody know what batch size is? Or batching? This is actually a really important concept in software.
Are you talking about when you feed, excuse me, when you're feeding data in a specific batch? So, you might do 10 sets of data at a time or 100 sets of data at a time to get like a good baseline or a good measurement. Because if you feed it all one, then you really don't know where the variation is.
You explain batching well, but it's not necessarily the reason why we batch. Anyone can think of Manisha got it right. Instead of grabbing one element, you grab 10 at a time, right? Can anyone think why that's important in software? Because this idea is not unique to training LLM models. Why would you think that batching is important? Sometimes you batch, sometimes you don't. It just depends on the use case, but batching improves what?
Process.
Speed.
Yeah,
Precision.
process, speed, and also you don't have to do
Precision.
10. Yeah, but you don't have to do 10 API calls if you can do one, right?
No.
Efficiency is really important, right? Imagine a library of books, and I don't know why I thought of this example, right? But we're gonna roll with it. Imagine a library of books, right? What happens in the library? People go in to check out books and return books all the time, right? Yes?
Yes.
Okay. You have a library where people physically, even to this day, walk in. You have been signed out because did someone sign me out? Did you guys see that? I don't know. I guess I was signed out. I don't know. Whatever. We're gonna keep rolling. All right. So library with a bunch of books. There's people going in and returning books, and there's people going in and checking out books. Is that true?
True.
Okay. Imagine this library has a website that keeps track of all of the books at that library, just in case someone wants to check it before they go rent the book, right? So you have a physical library where people can go in and grab the books, check them out, and return them. But you also have an online system that keeps track of all the books in that library that people can check, right?
Yeah.
How are you going to keep both of those consistent? That's why the use case matters here. It just depends what you're trying to do. Now, the minute that someone checks out a book, do you update that database every single time? Do you update it every hour? Do you update it every day? If you do it on every transaction, that's a lot of API calls. Does your use case warrant that? Sometimes it does, right? but a public library runs on public funds, maybe a 1 hour lag where they can batch, right? Grab everything that was checked in the last hour and checked out within the last hour will suffice. That's good enough. Maybe a 6 hour lag, maybe a 24-hour lag, where you can wait and grab all that data with one API call, one batch, and not individual ones. Make sense? So this concept of batching is actually really important. Kind of a little outside the scope of today's lesson, but not a problem. All right, so here's step 2. You actually start building the model. And you can actually build it, a little bit of it here, to kind of make sure that you have something started. You could literally just copy the first line from where? Assignment 1, right? Is this pretty close? Is this close? Yeah, this is pretty close. Let's roll with this. This is pretty close. Let's see how close we can get here. Cool, cool, cool. And notice that some of these are exactly the same. So I'm actually just going to leave this here. All right, so we have student performance, right? We're importing the model, right? We have our constructor. Cool, that's all correct. Then we have this first layer, right, of 13 and 30. And we also have, we deleted a bunch of stuff here, but can someone correct line 44? I'll give you the last layer. This is going to be a bunch of stuff here. More layers here. Which really just means more transformations here that get us closer to our final product of, what's our final product when this is done? On line 46. Five classifications, right? That's what goes here. So we know that this, it can't be 30 here. It could be just 10. That's the last line, right? Something like that. So this is going to look eerily similar to something that you already have, right? I deleted the was it the forward? Was that the forward function? But you can put it back. Def forward. And you can just kind of, just going to write pass. Just copy it from assignment 1. It's pretty much identical, right? Just going to pass in the layers, right? So then when you get to the training model, training the model, what do you think is going to go here? What's the first thing you need to do? Now it's time to train the model. You got to do all this. But before you do that, you need to do what?
Test it.
No, you test it after you train it, but we don't have a model right now. We don't have a model. So we have to, what do we have to do first? How about create it? Right? Creating an object or a class is known as what in software? We have to. It's a really fancy word with an I.
Inheritance.
Instantiate, but close.
Instantiate.
So model, right? And then I just create my student performance model, right? Performance model. Cool. All right, now model is ready to go. We got it. Now we have a model that has all this stuff. Awesome, right? Now we're going to jump into training, right? What do we want to write first? You could go a couple different ways here. Did anyone get this far by chance? We didn't get this far. That's okay. Totally fine. This is super new. I actually personally, between you guys and the recording, I can't imagine trying to learn AI and dev at the same time. That's tough. That is challenging. So if you're feeling a little overwhelmed, that's super normal.
I got a lot of it, but I did some research and stuff to get there.
All right, let's just take some notes here. We instantiated, right, our model. What goes here then? What kinds of functions do we have to define? They don't have to be in any particular. Eventually, they do have to be in order. But for right now, what do we need? What things do we have to do here after we instantiate? Right, even if you don't know how to do them, let's get some pseudocode going. Right, we created when we instantiated the model, and now we have to proceed to do what?
Loop through the data.
Yeah, right. I don't know how I'm going to do it, but I know that I probably have to loop through said data to train, keyword here, train model, right? Yes. After you loop through all the data to train the model, what do you think you have to do? You have to define a certain kind of function, right? That's called, anyone remember? I have to pull this up. Cross entropy loss function, right? For multi-class models, right? So you have to define the loss function. Am I missing anything else? I'll leave this here, right? You're also going to need your optimizer function. So that's it. That's the only thing that goes here. Boom. Figure out the order. This is the only thing you need here, right? And then evaluate your model. What do you think goes under evaluate? Let's just write some pseudocode, not necessarily if you know how to do it, but what are you testing here? Just give me, as long as you know that for now. Let you play around with it a little bit longer.
Your bias.
Yeah, you have to check what? How? It's a little bit of the bias. You have to check what the model is.
Accurate.
Yeah, you have to, that's the big thing here. Check for accuracy. Right? For example, model says it's A with a 80% certainty. And it's wrong. Is this an issue? This is the worst issue you can have, pretty much, in
'Cause
training these. Go
Is
ahead.
that because it's compounding? So if you're off by what, like 0.01, it's gonna continue to build and compound.
Yes,
So you're gonna get
as
further
you
away.
train the model. Yep. I kind of don't want to get into it, but you ultimately want to converge on the right answer. This is not in the reading. I'm going to pause the recording here. Alrighty, so you need to check the accuracy here. And I don't think this is covered anywhere, but the trick to the whole thing, guys, is you need to train the model as efficiently as possible to get to the right answer as quickly as possible. They call it convergence, right? If you can train your data, so the trick is to train your model with the least amount of data that's going to give you the highest level of accuracy. Can anyone tell me that why that's the goal?
Scale. Because if you can do it on a small set of data, you can do it on a larger set of data, and you're going to test less.
Yes, which ultimately means that you're being what with the money?
More efficient.
Yeah, you're being more efficient, so your profit margins are going to be larger. You guys remember a little while ago there was there was a lot of oh man, I'm gonna have to pause the recording again. Sorry. Alrighty, so as I was saying, oh sorry, as I was saying before we went on camera, the whole trick to the thing in LLM right now is trying to get the very best possible trained LLM for the least amount of money, right? If you hear a lot of the AI giants talk, especially NVIDIA, they'll talk a lot about, hey, this new chip that's 25% more efficient, right? And why you should buy it. Well, you can train models better, faster, cheaper, accelerate your AI push. So yes, this is a good thing. And then their stock jumps or whatever, right? That's what they're talking about. That's why it's so important. Okay, so the main thing here is really just to check for accuracy, right? And this is what you want to stay away from: a model that is confidently wrong about something. That's the worst. That's pretty much a death sentence in the AI world. If you're wrong, that's not that big of a deal. But if you're confidently wrong, yeah, that's the worst thing you can be. Right? Imagine a perfect LLM answer. Think of whatever a perfect LLM answer is when you chat with it or interact with it in any way. The opposite of that is to be 100% certain about something that is objectively wrong. Make sense? Like if I asked, I've never done this. I don't know if this would work. Let's try it live. What is the pull of gravity in meters per second? Are you sure? I'm pretty confident it's 10.7 meters per second. It did it right? It will correct you if it's wrong, right? And it's improved. You remember the early days when you would do something like this? It wouldn't be able to do that. So they have improved. So yeah, it was right. I expected it to be right, but I was just checking because I hadn't run something like that before. Anyway, accuracy, super, super, super important. And I don't think we're going to get to this. This is actually, ignore this for right now. I think we're a little, this is probably too hard, and that's okay. The only thing that this was is running a couple functions that would optimize your accuracy on this specific challenge. Let's just see if we get the first four. I'll actually go ahead and post. Let me see how far I want to go. I'll post up to number 2 right here, right in the Slack channel, right? That way you only have to work on training it and evaluating. If you can just do these two, I think we did pretty good for today. So I'll post number 2 here shortly. So that way you can just instantiate the model and then work on training it. Sound good?
Good.
Alrighty. I'm going to stop sharing. Boom. Boom. Questions so far? Okay, hopefully I didn't talk too much. I will open up the groups. Let me pause the recording. Retro forum, please take a couple minutes since we're going to finish a little early to give us some feedback. We got some good feedback about maybe moving the AI unit or doing more full stack. All valid questions that people have brought up. I am not king of the universe, but I will make sure that the king of the universe gets your feedback. Does that make sense?
Yes,
Yes.
sir.
Okay. I am going to give you one last homework assignment as a wrap up. Go through the last 2 weeks of the curriculum, of the AI curriculum. Skim through the README. Make sure you understand the big idea of each lesson. It's okay if you don't remember the syntax. It's okay if you don't even know how to do it. Totally fine. Do you understand the big idea of each lesson? Right? When someone says hallucination, you know what it means. When someone says RAG, you know what it means. When someone says binary classification, you know what it means. When someone says multi-classification, you know what it means. Does everyone understand that? I'm not asking you to write anything out. Just step through every day. Check if you have a general idea. Find out what it means. So if you hear it in a meeting, it doesn't go completely over your head. You at least understand that, hey, they're talking about training LLMs, or hey, your job is to, hey, help clean this data because eventually it's going to be typed to the AI ML team and they're going to do something with it. Make sense? Yes?
Yeah.
And as kind of a side note, I'm going to post a chat that I had that was worthless with my credit union. If you find yourself in a conversation with an LLM and it's terrible or it's really good, feel free to take a screenshot and post it in the India channel. I'll go ahead and start it here because I have a good example in it. And then we can kind of start breaking down the LLMs. Like, what are they doing and why is it responding in that manner? Make sense? And again, no pressure. Totally, if you find something that you think is funny, AI related, about something that we discussed, feel free to post it. I'm going to actually post one here shortly. Make sense? I will not talk anymore. Have a wonderful day, guys.